Hey everyone, welcome back to lesson 6C where we're talking about our unbalanced design examples. In this lesson, we're going to be focused mainly on how we implement our cow example and our pillow example into our respective softwares. So let's get started. With our cow example, just recall that we are looking at comparing 4 diets of 4 cows from 5 different dairies. Our total number of EUs is 19. Let's now go to our software to figure out how we get this ANOVA table. For the cow example in R, we want to first load our data. You can look at your data to see that, hey, there's a missing point at the same thing that we saw in our lesson. We want to convert our dairy and treatment into factors, and then we want to run our ANOVA. And this right here is the correct way to do it because we're going to put in our block first and then our treatment. So if we do it using our typical AOV function, you have your response, then you want to put in your block and treatment. Because R automatically defaults to type 1, you need to make sure you're inputting this correctly. So if we look here, we can see that our F and P value match what we saw in our notes. The incorrect way of doing this would be to put treatment first and then dairy. So this right here is incorrect, and I'll show you. We can notice it's going to put treatment first, so our F value is 907, which is going to be incorrect because we've seen that in our notes. And so our users, you want to be very careful. If you are using this AOV function, it defaults to type 1 sums of squares. So you need to put your block before your treatment. If you were doing another case like maybe Latin squares, you need to put all your blocks and always put your treatment last. Okay? Another approach, maybe let's say you don't want to remember to put your block first, is we can use the function lm plus the ANOVA inside the package called cars. So first we need to load our library, that's called cars. Then we're going to make an LM, which stands for a linear model, where we're going to put treatment first and dairy second. And then we're going to run this. All this is saying is go to the car package and use this ANOVA function. Use this model that we just defined up here. And this is saying use the type 3 sums of squares. So we already ran that. If we run this, notice that our treatment F value matches the right one. So it does the right thing. And notice that we put treatment first and then dairy. Now, if we go here and we put dairy first plus treatment, which would be the right way in the other case, you'll notice that it still gets you the same thing. So doing approach 2 and putting this type 3 will guarantee that you're going to get the right answer. Just like jump, it's going to default to type 3 sums of squares. By using this way, regardless of which way you put in your block or treatment, as long as you put this type 3, you'll be good to go. But if you still want to do it with the AOV, you have to make sure that your treatment is your last thing inputted into this equation, or else you will be incorrect. Another thing you might want to do is look at the LS means versus the non-LS means. What this is going to do right here is it's going to split our cow hay, so our response by treatment. We saw this in our last video. Notice that we have an NA here, and we want to calculate the mean. What you can also do with this sapply is put in any other variables. So this na.rm equals true is actually part of the mean function. So if we look here, na is part of the mean, which is basically saying if it's false, this isn't going to get us a value. But since we're saying true, it's saying remove this and still calculate the mean. So if we look at it, we get these mean values, which will match the
non-LS means in our notes. If we want to calculate the LS means, we have to load this library. Then we can do that's just random stuff. Load it, and we can see our LS means that match. You can also do it with the other one. This was from approach 2, this is from approach 1.
So from our ANOVA table, we had a large F, and in our software, we saw that our p-value was less than 0.001, which is less than our alpha. So I'm saying like our p-value, this was the value of our p-value. That's less than our alpha of 0.005. So we're going to reject our null and conclude that some of the 4 diets have significantly different nutritional values. Pretty simple. Now with our pillow, now let's move to our pillow example. So a company needs to compare the comfort scores where we had 9 types of pillow, we had 12 customers, which are our block, and the patients of our customers only allowed us to look at 3 pillows. So let's move over to our software to figure out how we got this ANOVA table.
Hello, data. We need to load our data, convert our treatment and block into factors, and then again, when we do the first approach with just the AOV function, we need to make sure our block is put first and our treatment's put last. And so this will get us the correct F value and P value. The incorrect way, just making sure you guys understand this is the incorrect way, where you put treatment and then customer is not going to get you the right value. We'll just show you that they're different again. That's not the same as this. Again, you could take approach 2 where you load your library car. The library car, since this is continuing off the last one, I don't need to reload it. Where in this structure, ordered won't matter if you put pillow first or customer pillow, as long as you put this type 3. And again, you'll notice that this matches the correct way. And down here, you can do your LS means.
So we see in our ANOVA table that we had a p-value of less than 0.0001, which is less than our alpha, which we're going to say is 0.005. So we're going to reject the null and conclude that some of the 9 types of pillows have a significantly different comfort score. Note that you can do contrasts with this type of So that ends lesson 6, and you should be able to now start your homework 5. Now this concludes our lesson 6 notes, and you should be able to start your homework 5. Have a great day. If you have any issues, come to office hours or post messages on Slack.